Hello. Okay, give me a shout if you can hear me. So this is very exciting. It's my first time being a host on it or a panelist on any Zoom thing. So do bear with me if I mess up. We appear to have all of our speakers. Oh no, we're missing one. So hopefully Simon Lee will arrive or raise his hand. There he is. So I can see him in the chat. So if somebody could raise Simon's privileges so that he can give us a talk later on. Great. Okay, so this is very exciting. So this is Lunch Bites. This is a format that we've been running at the University of Sheffield Research Software Engineering team for now a year. So this is the 10th edition. We've missed a couple, but we've had a year's worth of Lunch Bites. And this is a format where we in the RSE team try and facilitate members of the research and research software engineering community at the University of Sheffield, particularly to share tidbits and technical know-how with our colleagues and with the community. And this time we're very happy to be running this as a satellite event, a blended session with the SeptembRSE virtual RSE conference. So I'm just going to run through a little bit of information about what you can expect today. So we're going to have 3 roughly 10-minute talks after I finish talking. And our speakers are going to be Matt Williams from the University of Bristol, who has been very busy. I think he was just giving a talk in the last session as well. He's going to tell us about one of the first Python virtual environment concept, which is venv. And then we're going to hear from Simon Lee at the University of Dundee. He's going to tell us about Conda. And then James Graham from the Software Sustainability Institute is going to talk about poetry. So our questions are going to be on Slido as with the rest of the conference. So hopefully we can post the Slido link into the chat there. So I should just do that now. Thanks, Pete. And you can add your questions here, and when they appear, you'll be able to upvote existing questions while I'm sharing links. The slides that I'm currently talking from are at this URL, and you can check out all the links and information in there. So add questions to the Slido as we go along, and then we'll do a big Q&A after all 3 talks together, a sort of panel discussion. So I'm going to give a little bit of an intro to why we might care about Python virtual environments. So Python is, of course, an especially popular language in the research software and data science communities. And as with lots of languages, we'll import modules, libraries, packages at the beginning of our code and use the extra functionality from those later on. So this is just a snippet of code that I grabbed from some software carpentry teaching materials that I was teaching the other day. And you can see some really common libraries that you will possibly recognize. So we use pip, which is the usually bundled package installer for Python. We can install some packages and we can get some more information about those packages, and it'll tell us where we've put them. Now, I'm told that this is, I find out today that this is a special kind of Debian Linux sort of place to put packages. But the important point here is that basically those packages tend to end up in some sort of central location that depends on the particular Python that you're using. And when Python's looking for packages, when you're running your code, it'll look through some list of paths that depend on the current version of Python that you're running. So what's wrong with that? You might end up with a situation where actually you've got multiple projects that require different package or different versions of the same packages, or dependencies of those packages might conflict with each other. So actually it'd be quite useful to have slightly different environments, different sets of packages for different projects. That's kind of what I'm talking about now, dependency management. You might want to use a specific Python version in different projects. You might even have a project that's still using Python 2.7. And that's something that virtual environment management can help with. And also for reproducibility, when you give your code to somebody else, you might want, or run it at a different time, you might want somebody to be running exactly the same versions of those packages as you are. So, those are some of the kind of challenges that using Python can present, and something that virtual environments may be able to help with. So without further ado, I'm going to stop sharing and we'll pass over to our first speaker, which I believe is Matt.
Yeah, bear with me. I'm just getting myself set up.
Great, thanks, Matt.
And sharing my screen, which is that one. There we go. Looks like that's working. So I'll get started. Okay, good. So thank you, David, for the introduction. I'm going to cover very briefly that same sort of reason for doing this stuff before I get into the details of virtual environments. So I'm recovering. Why is that doing that? There we go. The core basic virtual environment tool that Python provides, called venv, or virtual environment. The terminology does get a bit muddled, so I'll try, when being specific, to refer to it as venv, as in the module or the tool that you run. So I'll brush over this, not spend too long on it, but the core problem that we're trying to solve here, as David just established, is that you usually have on your computer one centrally installed version of Python, the thing that runs when you type Python at the command line. And alongside that, as David showed with the dist packages bit, you tend to have some libraries installed as part of that, perhaps provided by your operating system, perhaps provided by, just decided to bundle it along with the distribution you downloaded. So that there is the logo for NumPy. So we've got Python and a module associated with it. You have a project you're working on, uses NumPy, all good, it's happy, it loads it, doesn't really care what version it's going to use. You then have a second project you're working on, maybe in parallel at the same time. It needs a newer version of that particular library, so that's fine. You can probably update and upgrade that library to the newest version. The problem comes when you're working on a third project, which perhaps is going to be clashing directly with it. It's not going to be able to work because maybe there's a bug in the newest version that it's not going to be able to work with. You're then in a problem. You can't downgrade it, you can't upgrade it, it's clashing, and so you need some way to solve it. And so the general model that, in some sense, all of the tools that we're going to be talking about today work by is moving the installation from being associated with the central install of Python and lifting it up so that it's associated with each of the projects that you're working on. And this is how VMs and virtual environments in general work. So it doesn't matter that project 2 and project 3 need different versions of the same library. It's okay because they're going to have their own independent versions installed, completely different places on your computer. And when those projects are run, they will refer to their local versions. So everything's good. The added benefit of this is if you're working on a fourth project, you're a very, very busy RSE, you might be working on a project that doesn't use NumPy at all. And in fact, you might even want to check that your project can run in the absence of NumPy. You might want to have a thing at the beginning that says, if NumPy is not here, then do this other thing. So you need to have an environment where NumPy is actually missing entirely before it's going to work. And so by having a virtual environment where there's nothing in there at all, you can test that that's working. And of course, you might have another project with a completely different library altogether, and you can do that. Everything is separated and isolated. So to create a virtual environment using the venv tool, which is part of core Python, you first say which version of the Python interpreter that you want to use. By default, on my computer, Python 3 is linked to the latest version of Python 3, but I might have multiple versions of Python. And as long as I specify which Python interpreter I want to use, which version, the environment is going to be associated with that version. So this allows you to test on Python 3.6, 3.7, 3.8, and have separate virtual environments for each of them. You tell it to run the venv module, and you tell it to make a directory called, in this case, my_venv. You can call it whatever you want. It's just a directory sitting on your computer. It's going to do some magic, create the virtual environment, and that directory is the virtual environment as far as we're concerned. You then source a particular script inside that virtual environment, and that does a little bit of magic to make it so that that virtual environment is the active one. It's the one that if you run Python, it's going to do the stuff from that environment. When you're finished with working on that particular project and you want to change directory and work on something else, you run the deactivate command and it undoes the magic that it did earlier. And you're back to, if you run Python, it's going to use the system version of Python. So you activate it to enable all the features and you deactivate it when you're done. And in that window, anything you do with Python is going to be looking at those modules, at those tools inside that particular virtual environment. So let's have a little look at actually what's inside a virtual environment. I'm going to go a little bit behind the scenes here because VMs are simple, and so it's worth understanding what happens behind the scenes. So it's a directory called myvenv, and inside the bin folder, there is a copy of the Python interpreter. In fact, it's not even a copy, it's just a symbolic link to it, so it doesn't even use up any more space. And so you can check here, if you want to check exactly which version of Python am I working in here, look at where that symbol is pointing, and it will show you. There's a little magic file down there at the bottom. That's the thing that makes this directory a VM. That config file can be as small as having a single line of config in it. And by default, it's only got 3. It's very, very simple, but it's that thing that does the magic. There's an activate script, the thing that I sourced to activate before. And there's pip and a directory for the packages to get installed to. So it comes with its own local copy of pip, which knows to install stuff into the local site packages directory. So everything gets kept inside this folder, all the tools and the libraries that you install. So venv by itself doesn't do anything. It doesn't even do that installing bit. It just creates that environment and enables you to turn things on and off. It's a minimalistic tool which decides to do one thing and one thing well. So it only gives you that sense of isolation, like you're sitting out there on a desert island by yourself, no other packages as far as the eye can see. So if you want to install anything, you have to use pip. So pip and VM together provide you with this ability to manage your dependencies locally. And once they're together, it's party time. You've got an isolated island with all your friends there, all your matplotlibs and scikit-learns you could ever eat, and you can just go ahead and get your work done. So if you want to actually install something into your virtual environment, once you've activated it, you can just do a pip install. The activate script has set it so that the version of pip that you run when you just type pip is the one from your virtual environment, and it will install it inside. So if we install numpy, we get the f2py library showing up, and we get our module showing up here. So that if we ran the Python interpreter inside here and imported numpy, we would get this particular version. And that's exactly what we want. It's how it's solving this whole problem. So you've got your isolation. You can install any particular library you want. You know they're going to end up in the right place. But if you want to be sharing your code and distributing it and talking to other people about what you're doing, you shouldn't just write in your documentation, oh, by the way, to make this work, install these 3 Python libraries and give some example pip commands. You should document it explicitly by putting it in a requirements file, by saying, I want this package at this version. So if you're writing an application, you should be really strict with the versions you require. I want exactly this point version because you've tested it and it works. If you're distributing a library, you want to be relaxed and say it works with version 1 of numpy and everything's good. And this allows you to make it easy to destroy and recreate virtual environments. They should be ephemeral. Throw one away, make a new one, keep it rolling. That's how you get your flexibility and your reproducibility. So an example, requirements.txt, it's got a few different things in here, numpy, matplotlib, and scipy. You see you've got a little tilde equals there. That's how you say it should be on this version, but any decimal places after that don't matter. So it will be 3.4 of matplotlib, point something. It doesn't care which. And as long as your virtual environment is activated, you can pip install with -r, give it that file, and it will install all that stuff, and it will do all of the magic that needs to go on behind the scenes. And particularly with newer versions of pip, it can handle binary dependencies. So if you want to install scipy, you don't need to have a C++ C Fortran compiler on your laptop. It will download it precompiled. Binary packages are now supported, and they work really, really well. It can also solve complex dependencies. If you've got different things which need not quite clashing, but overlapping version numbers, it will handle all of that for you and make it all work out. So what I use venv for, compared with other tools, is for when I've got that end user script situation. I've got an analysis that I'm doing. There's some notebooks, perhaps, some scripts, some local libraries I've written to perform a task, put it in a Git repository with requirements.txt, and then that environment is all wrapped up and nice. Something which I'm going to download and run as a script type environment. So I can git clone, go into the folder, make a virtual environment, install the dependencies, and run it. And it makes that whole process very, very simple. And because it's standard core Python, it's supported by everyone that needs to understand it. If I'm in a situation where I want to be creating libraries that can be installed by other people, that's when I might use Poetry. Or if I'm dealing with things which aren't just Python dependencies, which are some funny binary dependency, then I might go to something like Podman or Conda in those situations. But there's definitely a really large niche where VMs keep it simple, they're understood, they're common, and everything keeps on working. So just to summarize the main points about VMs as I see them. So they are part of core Python. They are standard and they are default, and everyone should be comfortable using them and understand how they work, even if you then choose to use different tools which layer up on those concepts. They are simple and simplistic. They do one thing, and I think they do it well as long as you're working within the bounds of what they're designed for. If you want to start building outside of that, you add in pip to do your package installation and something like setup tools to do your distribution. Or if it starts getting complex, you start looking to other more advanced tools. And that's me. So thank you. I'll hand back to David.
Fantastic. Thanks, Matt. That was amazingly comprehensive for a very short talk. I definitely learned some stuff. Simon, do you want to get set up? Simon's going to tell us about Conda. Whilst that's happening, do you remember to put any questions that you have for Matt or for any of our other speakers at the Slido? That link is in the chat. And also remember, you can upvote questions that are already there, and we can answer the most popular ones first. So we've got Simon. Are you there? I can see you in the participants list, but oh, it's disappeared. That's unfortunate. James, are you ready? We can. Oh, Simon's reappeared. What should we do? Simon, give us a shout if you're ready to proceed. Otherwise, we can.
Sorry about that. I tried to full screen my browser. Unfortunately, F11 is also the turn Wi-Fi off button.
No problem. If you're happy to go ahead, then
yep.
We can share now. Otherwise, we can give you a minute.
Yep, I'm good to go. Let me just share my screen.
Great.
Right, can everyone see that and hear me clearly? Come on.
Can't see the slides, I'm afraid.
Okay, let me try something else. Sorry, I think my laptop might have crashed.
If we do need a bit of a rearrangement, Simon, I'm happy to swap round while you sort out some tech issues.
Sorry, I think
should we do that? Should we go with James first, and Simon, you can see if you can get things fixed?
Yep.
Yeah. Okay. No worries.
Thanks, James.
I cannot start screen sharing while Simon is screen sharing, so it thinks you are screen. There we go.
There we are.
You should hopefully in a moment be able to see a terminal. I'm James Graham. I'm going to talk about poetry. I'm an RSE at the University of Southampton, where I work for the Southampton Research Software Group and the Software Sustainability Institute. I've made the brave and/or stupid decision to not prepare slides, and we're going to do this as a live demo. So should be okay, but there is no backup plan. So poetry. Poetry is a little different, I guess, in that it's not really a virtual environment manager. Poetry is focused around being a sort of packaging tool for Python projects, and it just so happens to do a load of environment stuff as well. So I have a very, very fancy project I've been working on. If we look at this file, it's a single file. And I've spent a lot of time working on this, as you could probably tell. What it does is it creates a NumPy array and then it prints a NumPy array. So obviously this is going to need NumPy to run. I don't have NumPy actually in my base system Python. So when we try and run that, it fails, as we might expect. So we're going to need a virtual environment. We're going to need to install NumPy into that. So Poetry is a little like a cross between Conda and NPM from JavaScript, if any of you are familiar with JavaScript. So the first step is like we would for NPM. We need to create a config file. So Poetry init takes us through a little walkthrough thing. We'll accept the defaults for pretty much all of these. So default package name, default version. Not going to bother with the description for now. It gets the author, I think, from your global Git config. License, what versions of Python it's going to be compatible with, and then it asks you about defining your dependencies. So we're going to say, yes, we do want to define our dependencies now, and we know this depends on NumPy. So we select NumPy, it goes away and searches for things that might be what you mean. And we're going to say pin this to version 1.20 and then any patch release within that. And that's the only dependency we have. So if we hit enter again to skip, we then get asked about development dependencies. So this is something we'll talk about in a little bit, but there's a separation between runtime dependencies and development dependencies, which I find really useful. So we'll say no to that, and we'll confirm the generation of our config file. So now, because Poetry is not really a virtual environment tool, it doesn't really want us to have to think about virtual environments too much. So to create the virtual environment, install the packages, we could do Poetry install. So that goes away. You can see here, it creates a virtual environment for us, installs our dependencies into it, and installs our package as well. Then we can do Poetry run, and then the thing we want to run, let's run that actually with Python 3. And now you can see, rather than our error that NumPy is not installed, we've printed this NumPy array. So that's the result we wanted. Okay, so that's the core flow. If we look at what we've actually got, so if we do LSA, you can see here we've got a directory called .venv, and sort of in the internals of Poetry, it's all handled along the same lines as the venv tool that Matt was talking about. So this is as far as we need to care about a bog standard Python virtual environment that's managed automatically for us. By default, those virtual environments will go in a sort of centralized location like Conda does, which I suspect we'll hear about in a minute. But I prefer to keep them with the project. So I have in my Poetry config told it that I would like to create the virtual environments in the project directory. So I like to keep everything together, but that's a personal choice. We also have this pyproject.toml. So this is the config that we created. It's got a section that describes the package that we're developing, sections that describe the dependencies, and some other optional ones that we can add. And the last file it's created is this poetry.lock. So this is a lock file. And if any of you are familiar with JavaScript, this is essentially our guarantee that we're going to get exactly the right versions of a package. If you have this lock file and you install packages, you will get one of the exact versions that matches this lock file. However, Poetry does other stuff. So it's a packaging tool. We're going to sort of take some steps towards making a package. So let's go in and edit this and add one of the optional sections. The optional section we're going to add is a scripts section. And we're going to add a script called Poetry Demo that refers to this Python file that we have. So this is the module, sorry, the package name, the module name, and then the function within that package. So if you're familiar with the setup.py, this is very much similar to one of the parts of that. We can do our poetry install again. I'm not sure that's strictly necessary, but no harm. And then we can run it as a command directly and we get the same result. So currently we're doing poetry run to say, go and activate this virtual environment and run this command effectively within the virtual environment that you manage. However, that's sometimes a little bit verbose. So we can actually also, if we use poetry shell, this is the equivalent of what Matt showed us, where you source a virtual environment to activate the virtual environment. So this is say we've activated the virtual environment, it works, and basic Python virtual environments work with all range of shells. So if you're using a more unusual shell, that's fine. And then within this shell, because the virtual environment is active, we can then run that without having to do poetry run. The final couple of things. So the development dependencies. So we can add a development, or we can add any dependency by doing poetry add and the name of the dependency. If we only want that dependency for people who are developing the software, we can do --dev, and we add that to our there. It'll go and install all the dependencies, and that goes in an extra section in this here. So how this works is when you've packaged up your project and given it to someone else as a distributable, a wheel, or however you want to distribute it, if they then install it, they will get everything in the dependencies section. But if the person who is installing it is using poetry and has the poetry config files, it will install everything from both of these sections. The idea there being that your poetry config files are in your Git repo, and if someone has checked out your Git repo and then installs the package, they're probably doing that because they want to develop it. So there's a nice separation between runtime and development there. The last thing I'm going to show is, I guess, the point of poetry and why it exists. All of the other virtual environment stuff is sort of ancillary to this, is poetry build. So this will build our project into a distributable Python package. So if we ls the dist directory here, we can see we've got this new Python wheel. So what we're going to do is we're going to cd app. We're going to make another directory, cd into there, and we're going to use the tool that Matt showed us just to create a virtual environment quickly. We're going to activate that virtual environment, and then we're going to install the wheel, the Python distributable, from our other directory that we've just built. So that's gone away. It said, okay, we need to get NumPy, that's a dependency, so it installs NumPy in the project. And now we are in this virtual environment and we've installed this package. We can call the program using that script that we added to the poetry config. Just to show the difference between dependencies and development dependencies, we can hit freeze to show us everything that's installed by pip within this environment. And we can see that Flake8 isn't in there. So evidence that anyone installing it via the wheel doesn't get your development dependencies, and they only get what you expect them to in the runtime. We can go further than this, and poetry does then let you push these wheels to the Python package index for proper distribution, but I don't think this project is quite yet ready for distribution with with other Python developers yet. And that's everything I have to show on poetry. Thank you.
Amazing. Thanks for that demo, James. That was really useful. So just another reminder to pop questions in Slido and upvote them if you want to hear the answers to those. Simon, let's try again.
Is this any better?
We can see. Fantastic.
Right. So I'm not going to full screen it again. I'll just leave it as is. I'll paste a link. I'll paste a link to my slides as well if I can find a chat window. Right. So hi, I'm Simon Lee. I'm a kind of software engineer and systems engineer at the University of Dundee. So today I'm just going to talk to you a bit about Conda. And most of what I say is going to be based on personal experience rather than say what Conda is officially for, what it says on the webpage. And that's all based on sort of working 3 different roles. So currently I'm working in the Health Informatics Centre at the University of Dundee on trusted research environments. If you were in the previous session, you've heard James talk here about Turing's safe haven. We've got something similar in Dundee. Before that, I was predominantly working open source at the open microscopy environment, open data. And in addition to all that, I'm also a Jupyter co-maintainer. If you come across mybind.org, which I'll mention later, I help maintain that. So the first of all, what is Conda? So Matt gave a very good introduction to VMs. It seems fairly comprehensive. Why is there yet another package manager? So the first thing is, in contrast to most Python package managers, Conda isn't just for Python. That's both a very big strength and also one of its big weaknesses, as we come to in a bit. So just to give a bit of background to Conda, one of the main things is that it's self-contained. So what do I mean by this? So when Matt was talking about VMs, they're saying you can pip install things like, for example, NumPy or SciPy. Nowadays, NumPy and SciPy are pre-compiled for most say systems. So if you do pip install NumPy, you'll download a pre-compiled binary for the platform. It will all just work really nicely. But back when I started using Conda several years ago, that was a bit hit and miss. Sometimes it would work, sometimes it wouldn't. So if you try and do pip install NumPy, it would download the source code, it would compile it. Sometimes it would work, sometimes it wouldn't. Then maybe a week later, you try and update a package, it would recompile another package, that would break another package. It turned into a complete nightmare. The other advantage of Conda is because it can install non-Python packages, it means, say, if your Python library depends on, say, a C++ library, different project, Conda can actually take care of that. So again, to give a concrete example, a few years ago, I was trying to use something called PyTables. That's a Python module that interfaces with HDF5. So PyTables is a Python module, but at the time, it required you to download the HDF5 compiled C or C++ library. That's a bit of a pain because you have to go to 2 different places to install it. The other problem was if you accidentally update your HDF5 library, that then breaks a Python module, but it's directly linked to it. Whereas with Conda, all the dependencies are sort of interlinked. So if you update one package, it should automatically update the other or not. And one of the big third benefits is that you can install any software that's been packaged for Conda. So I actually use this just because it's quite convenient. So for example, say I want to install R or some R packages, I can just do Conda install R. Similarly, I can install Git or any other random tools I need. So for example, I'm an infrastructure engineer. I bring up a lot of cloud infrastructure. So you do Conda install Terraform. You don't have to go to the Terraform download page and figure it all out. And you can say you can install anything like C and C++ Fortran compilers if you want. And for me, that's a big benefit in my current job. So previously I was working on Linux and Macs. Now my main work laptop is Windows. I find actually that's a big change to how I work. I find Windows a lot more restrictive. And using something like Conda where everything's pre-compiled, it actually works really well for me. What are some of the other benefits of Conda? So with something like PyPy, there's a single PyPy server. If you do pip install NumPy, it will always go to that PyPy server. You can, for example, set up your own. I don't know anyone who actually many people who actually does that. With Conda, it's slightly different. So with Conda, you do have what are called channels. So if you're familiar with something like, say, Ubuntu, with Ubuntu, you can do apt-get install the packages, but Ubuntu and Debian also have this idea of like add-on repositories where people can say build their own repositories or modify packages. Conda is kind of the same idea. So Anaconda, who are the original developers of Conda, have their like main default channels. So if you just do Conda install, say NumPy, that's where it will be installed from. But anyone can sort of set up their own channels. And there's kind of two particularly noteworthy ones I thought I mentioned. So Conda Forge is a big community supported one. So I emphasize community supported as opposed to say the default one which is supported by Anaconda, who are a corporation. They are the originators to Conda, but ultimately it's run by a single organization. Whereas Conda Forge is much more community supported. We've got thousands of packages there, and anyone can propose new packages. So I mean, I've done a few. So Conda Forge is very good for say general purpose packages, both Python and other random things like say Terraform or Git, for example. You also get a lot more specialist channels. So for example, if you work in bioinformatics, there's the BioConda channel, which specializes in bioinformatics packages. And say anyone can sort of create your own. The third big advantage of Conda is that it's intended to support reproducible environments. So I think for James kind of just mentioned that's one of the goals of poetry as well. So there's some redundancy. I guess the difference is that Conda is a lot older than poetry. So at the time, this idea of sort of having a fully reproduced environment was relatively novel. But I mean, it works in the same way. Once you've say installed all the Conda packages that you want for the environment, you can run something called Conda env export. That will spit out a text or YAML file that lists all your packages that you've got installed, including versions. And I think nowadays you can get down to some sort of hashes as well. I can't quite remember. So the advantage of that is that first of all, it means you can reproduce the environment, both say on different developers' laptops. But it's also good from a scientific reproducibility point of view, because it means you can give someone your environment file that has all the dependencies with the exact versions, and hopefully someone else can then install those dependencies into their own Conda environment and have the exact same dependencies you want. And again, because this Conda is not just for Python, you could also use this for R packages. So which version R are you using? What R dependencies are, or even say other applications. So for example, if you're using a particular version of a bioinformatics tool, that can be encoded in your environment file. So I'm just going to give quick examples of how it works so you can see what it does. And the first thing you do is you need to download either Anaconda or something like Mini Conda. That's basically downloading the Conda tool. I personally use Mini Conda. It's just a lot smaller. It doesn't come with a lot of the package. And then after that, it's very similar to how you create virtuenvs, really. Instead of doing vn, just do Conda create. In this case, I'm creating an environment called demo. And as you can see in this one, I'm installing Python, a particular version of Python and JupyterLab. So because Conda isn't just a Python package manager, it's a general package manager, you can also use it for, say, choosing what version of Python you want. So in this case, for example, I'm installing Python 3.8, and you can install many, and then you can create a separate environment with other versions. And see, once you've done the Conda create, you can activate it, run your applications just like with the venv. And then after you've activated it, you can also modify it. So for example, you could say, I want to install TensorFlow. In this case, I'm just saying install the latest version of TensorFlow, but you could obviously have the full version specification there. And just an example set of creating other environments. In this case, I'm creating another environment called Demo2 this time. And as you can see, I'm installing Python 2.7. So if you're one of those unfortunate people who has to maintain some legacy software that still doesn't work with Python 3, that's no problem. You can install Python 2.7 alongside all the other versions of Python. And say, if you want Node.js for whatever reason, install that in the same environment. So this all sounds great, but what are the disadvantages? So these disadvantages also come about by the fact that everything's self-contained. So because Conda installs all the libraries that it depends on, for example, it installs OpenSSL, all the basic libc libraries and so on, it ends up taking a lot of space. So it's not unusual to have a Conda environment that works at several gig. This is in contrast, and obviously because it's installing like the base Python as well, so it all adds up in terms of space. The second problem is the dependency solver can be quite slow. So because when you Conda install a package, whereas with pip install say NumPy, it's just checking the dependencies of NumPy. If you do Conda install NumPy, potentially it's got to check the dependencies of NumPy and then all the non-Python dependencies that it ultimately depends on. And that dependency solver can be quite slow. There are faster options, something called Mamba, for example. The third big disadvantage is that you need that Conda, because Conda is a separate packaging system, you effectively have to repackage any Python package for Conda. So for example, if you can do pip install, say SciPy, in Conda for someone's repackaged SciPy as a Conda package. So there are some tools to help with that, but it is an additional barrier. Having said that, once you've created a Conda environment, it behaves just like any other Python environment. So you can also use pip install inside your Conda environment anyway. So it's not the end of the world, but something to be aware of. And the final disadvantage, which is kind of general for anything really, is that the binaries might not be optimized for the system. So if you do Conda install, say TensorFlow will have been compiled, but it won't be optimized for the specific hardware. So for optimal performance, you're going to want to compile TensorFlow for, say, whatever GPUs you've got, or perhaps your CPU architecture. Because this has to be pre-compiled in advance to run on most systems, you're going to lose out on some of that performance. But again, that's going to apply with any binary packages that are uploaded to, say, PyPy. It's just how it is. So I'm just going to take you through three concrete use cases where I found Conda particularly useful. So the first one is working in trusted research environments. So for anyone who wasn't in the previous session, a trusted research environment is kind of an environment for data analysis where the data is very confidential and you want to put in a lot of controls to restrict accidental egress or ingress. So typically you might say your environment has no public outbound network access. So you can't just install packages. You have to find another way of getting them in. That's one place where Conda's reproducibility support comes in. So for example, you can create your Conda environment. You could then use something called Conda pack. And because Conda is mostly almost self-contained, there's this tool called Conda pack, which pretty much zips up the Conda environment and all its dependencies into a zip file. That means you could then take it through the security assessment, for example, check there's no malware in there. And then you can effectively copy it to an air-gapped system. In practice, with a secure research environment, there is limited network access for admins. But in theory, you could copy your exported Conda environment to a USB drive, copy it on a different system, unzip it, and it would all work. In theory, that's possible with, say, other tools, but it depends. But you have to, yeah. But because with something like the base Python, you might have dependencies on other libraries. It can be quite tricky to get that working, whereas it's a lot easier with something like Conda. Second case is compiled Python packages. So I kind of touched on some of this earlier. So in my previous job at the Open Cross environment, we had a library called MeroPy, which is pure Python, but required a compiled library called ZeroC Ice. The problem with ZeroC Ice is it depends on OpenSSL. And if you're on Linux, if you ever delved into Python packaging and binary packages and PyPy with Linux, you may know that actually you can't really distribute a compiled Python package that depends on Linux OpenSSL. If you're interested in why, I can go into details, but basically it wasn't possible. That basically means if you try to pip install ZeroC Ice, it would try and recompile it, and that is a massive pain. Whereas in Conda, because it's self-contained, Conda includes a version of OpenSSL. So you can compile zero-C ice, and Conda again takes care of your dependencies. And the final use case comes from this tool combine binder, and it just emphasizes how useful it is as a reproducibility tool. So the idea of iBinder is that you can take a Git repository, you put the requirements in the file there. So for example, requirements.txt work. Obviously, the advantage of Conda and what Conda files is that you can have other tools like R or whatever other tools, for example. MyBinder.org then takes your, say, Git URL, reads all those setup files, builds you an ephemeral environment up in the cloud, and you can log in and then say run your Jupyter notebooks. So it's really a tool to emphasize public reproducibility and an easy way of testing that. So just to sort of summarize, when is it worth considering Conda? The first reason is when the Python packages are complex dependencies. So basically, pip install ends up going through ends up compiling packages, for example. That's a good use case. Or if, say, you want to install some non-Python software that as part of a self-contained reproducible environment. The other good reasons are if you have to deal with multiple versions of Python, because Conda would create your virtual environment with whatever Python you want. Is that reproducibility, as I already said? And I said, bigger advantage, at least from a personal point of view, is on Windows, because I just find things are improving, but I still find it difficult to try and get things compiled on Windows or install other bits of software. So what do I use day-to-day in practice? So Windows, Conda for everything, it's just easier. For Linux, I'll typically use Conda to create a Python environment and to store, say, some base dependencies, or where I want to install things, other tools like Terraform, for example. And then on day-to-day, I typically use just pip, because it's actually quite easy. Why don't I use other things like, say, poetry, venv? I'll be perfectly honest, mostly inertia. I mean, there are loads of other tools. I would love it if there was a standard tool in the Python ecosystem that everyone agreed on, but it isn't. But I'm happy to consider others, and I've been very glad to see James's presentation of poetry. So thanks for listening.
Great, thanks. So we can move over to questions now. So we've got lots of questions in. So we're probably not going to get through all of them. So if you upvote the ones that you want to hear the answers to, then we can prioritize, make it a popularity contest, particularly the questions that have come in during the last talk, which may have not had as much time to go. So if all of our speakers can unmute and maybe share your cameras if you're happy with that. And I don't think any of these questions are necessarily specific to any of our individual speakers. So we'll just have a bit of a scrum and see who wants to answer each one. So starting with that top one. So pipenv uses venv and pip. How does that differ from using them directly? This is about one that we haven't covered, pipenv. I don't know whether any of our speakers have any experience with pipenv.
Go for it, James.
Yeah, didn't know if you were going to talk there, Matt.
No.
So I've not used pipenv, but I am aware of it and have read a bit about it. It seems to have a model sort of along the same lines as poetry, where you'll do something to the effect of pipenv run, and it will handle the virtual environment and the interaction between venv and pip for you, as far as I'm aware. That match your understanding, Matt?
Yeah, I mean, it seems to do the same thing. It's taking those various tools underneath and wrapping up so the workflows that you as a developer actually do are integrated together. It's like, you know, you've got your venv and your pip and your twine and your whatever, puts them all into a package, does the thing. So it makes your life easier, I think, to answer the question.
Is it the Python Packaging Authority's solution to poetry? So having had a quick look at it, it seems to have a lot of similarities.
No, that's mildly controversial. The fact that it belongs to the Python Packaging Authority does not seem to imply that the Python Packaging Authority recommends its use or supports it. And it's a similar sort of tool though.
Okay, let's move on to our next question. This one's about poetry. It seems like it's specifically tied to PyPI packages. Can you also install a Conda package through poetry?
Not that I'm aware of, no. It's a separate divergent branch of evolution. I have come across a tool which will allow you to export a poetry set of dependencies to then create a Conda virtual environment with those dependencies. So that's probably the crossover you want if you do specifically want to use both of those tools together.
Okay, next question. I don't know whether this also applies to Conda, actually. I'm interested to know if there's any difference between them, but what is the underlying magic that occurs when one switches VMs?
I can answer that. In fact, I have a slide to answer it, but I will just describe it. At its core, all it does is set the path. So as long as you're accessing the version of Python that's inside the virtual environment, then Python handles all the actual virtual environment magic. There's no other environment variables hanging around. Basically, just the path, and that's all it does. It's nice and simple and direct. I imagine it's similar with Conda, but there might be some library stuff that Conda does as well for binary dependencies.
Yeah, it's pretty similar. I mean, I think when you switch VMs or when you switch Conda, all you're doing is setting your show environment variables. So with Conda, this we'll take account of shell, say using Bash or say PowerShell, we'll set some variables. It's both pretty cool and fairly simple.
Okay, great. Next question, rattling through these, is it advisable to version control your poetry.lock file in collaborative projects? Is it platform specific? Maybe this applies to pip_file.lock for pip_env, and maybe there's a similar question for something like your environment.yaml file for Conda, ways of crystallizing your environment.
So with poetry specifically, I'm seeing quite a lot of poetry questions here, I guess, because that's the one by far that people are less familiar with. It's the least used of the three. That is your personal preference, whether you commit that lock file. The documentation doesn't recommend either way. However, I personally prefer to, so that I know that other people developing the project with me have exactly the same dependencies, so we're encountering exactly the same errors. But then it's also important to test with potential other versions of dependencies as well for release.
I think Matt's speaking, but we can't hear you.
Yeah, you're muted, Matt.
Sorry, I muted myself. If you're packaging an application, then it's generally advised to put your lock file in so that you know that they're getting the exact environment you started with. If it's a library that you're packaging up, there's less reason to, because it's going to be combined with other libraries which will have different versions. And so you just rely on your version constraints rather than your exact thing. And then you just run it through CI to make sure that everything's consistent.
Okay, thanks both. And I think we've probably only got time for one more question, so I'll say a few words at the end, and I did say we'd finish by 1. I appreciate that Matt's been in sessions for a long time, and so has everybody else maybe. And there's questions further down the line I'd like to hear the answers to, but I have to go with the vote. So the last question is also about poetry. Does poetry have the equivalent of installing extras, something like pip install my package with this, that, or the other?
Absolutely. Everything you can do with pip install sort of version constraints and extras you can do in poetry, and the syntax is the same within that file. It also will do other stuff like constraining particular versions of packages to run on particular versions of Python or on particular operating systems. So you can have a different set of dependencies or different versions for Windows, for example, which is quite useful.
Okay, thanks, James, and thanks to all our speakers for answering all those questions. I'd love to hear the answers to absolutely all of these. So clearly there's lots of demand for information about virtual environments in Python. And I must admit, I did put this session on so that I could save myself some research time and just draft in some experts to tell me all the answers. I'm just going to share my screen here. Just to say last few things. Thank you very much to all of our speakers and to our helpers. Thanks to Pete for managing the questions and all the people who asked and upvoted questions. I'll just speak about some future events, and I have to mention SeptembRSE, which is the online research software engineering conference, which is ongoing at the moment until the 30th of September. lots of different types of events. Registration is open throughout the event, I understand, and it's only £15 for members of the Society of Research Software Engineering. And there's a link there. You can open these slides if you want to get access to those links. The next Lunch Bites is in a month. That's going to be on MATLAB, so switching language completely. And we're really looking forward to that. We've got speakers both from the University of Sheffield and from MathWorks itself. A couple of links there to get access to some more information there. If you want to hear about more events from the Research Software Engineering team at Sheffield, please join our mailing list. There's a link for information there. Follow us on Twitter or check out our website. With Lunch Bites, we are always looking for session curators from across the research, software engineering and research communities at the University of Sheffield and beyond, speakers and also suggestions of themes for sessions. So please contribute. It is a community initiative, so we'd like to hear more about that. So with that, thank you very much, and thanks to all our speakers and everybody for attending and being involved. It's been great.